Hi everyone. Okay, so in this lesson we're gonna take the idea of congruent figures and extend it a little more. And like we talked in class, you know two figures, if they're congruent, you know that all corresponding parts are congruent. And it goes backwards. If you could take two figures and say you could make a correspondence from one figure to another and say all corresponding parts are congruent, then you could also go back and say that the figures are congruent. Or if you know they're congruent, you can say that all corresponding parts are congruent. Okay, so if you have something that has like, let's say 5 sides, like a irregular pentagon, so we have 1, 2, 3, 4, 5, and then I have another one and I want to check if A, B, C, D, E is congruent to Q, R, S, T, U. Are they congruent? Well, I'd have to find something that corresponds, let's say, to AB, and let's say it's QR, and if I can prove that BC somehow I know is congruent to RS, and this side is congruent to this side. Here we have these guys congruent, and here we have these guys congruent. But then I also have to check the angles. So in a pentagon, so in a polygon with 5 sides, you would have to check 10 different pairs of corresponding corresponding parts. Okay, you have to check them to see if they're congruent, to find out if the figures themselves are congruent. Okay, and another way, like we talked about, is, well, if I could take one figure and move it somehow, flip it, move it, rotate it, and I could get all the points to match up, I can also say they're congruent. Okay, but the goal is to tell you, well, I know that in any regular or irregular polygon, I have to check every pair. But in triangles, it's interesting because you don't need to know all 6 parts in a triangle, right? You just have to find 3 pieces of information. So in a triangle, if you find the right 3 pairs of information, then you can say the triangles are congruent. Okay, so this is the first one, side, side, side congruence theorem. Okay, basically what this says is if 3 pairs of corresponding sides are congruent, then the triangles are congruent to each other. Okay, so how we can write this algebraically, if you look in the picture, we know that AB is congruent to DE right here. We know that BC is congruent to EF, and CA is congruent to DF. So if we know this, then we can say triangle ABC is congruent to triangle DEF. And let's just double check that I named it right. So we got A between 1 tick mark and 3, and so is D. I went to B, which is 1 tick mark and 2, and E is between 1 tick mark and 2. Okay, good. So this is the congruence statement. And now, once I know this, then I know that not only are the 3 sides congruent, but also the 3 corresponding angles are now congruent. So that's actually an awesome piece of information. since the triangles are now congruent, we can now also say that all corresponding angles are also congruent. So it's a shortcut because I didn't have to check all 6 pairs. Okay, so another congruence shortcut is called SAS congruence. Okay, so now what this says, and you have to be careful, is that if I got 2 pairs of congruent sides and the angle in between those 2 pairs, we'll call that the included angle, they're congruent, then the triangles are congruent. Okay, so let's say that again. If 2 pairs of corresponding sides are congruent and the included angles are congruent, then the triangles are also congruent. So let's write this algebraically. Look, we have AB, right? AB is congruent to DE. And if I look, then I got another side, AC. AC is congruent to DF. Okay, so I got my pair. Now, for it to be in an included angle, it has to be exactly between these 2 angles. And the only angles that do that is angle A here and angle D here, because they both have a tick mark. So angle A is congruent to angle D. And we know these angles are included. Okay, so you know this information, this and this. So if AB is congruent to DE, angle A is congruent to angle D, and angle AC is congruent to angle DF, then triangle ABC is congruent to triangle DEF. Okay, and again, like the other one, the information that we didn't know, like the 2 other angles, I didn't know what this angle is, or this one, or here, but and this side, I don't know compared to this side. But because I put the triangles are congruent, now I can say that the corresponding angles are also congruent. And here's a good example in how to use these theorems in a proof.